Hello everyone, September the 1st. Alright, let's hit it. Hit it right in the head. Hit it right where it is. Find the number of ways to place people. 2D array of size n times 2, representing integer coordinates of some points on the 2D plane, where points I is x and y. Count the number of pairs of A, B, where A is on the upper left side of B, and there are no other points in the rectangle they make, including the border. So none of the pairs. Okay. So it doesn't matter A and B. What we want to do is just find this with a one person here and one person here. That's it. Right? We just want to find this arrangement. So in the second example, we can see that we have this is arrangement, this is arrangement, but only two, because this one doesn't count. We have another one in between. In this case, we have this counts as long as it's the upper left side. Okay, so upper left side. This one doesn't count because we have another one. N is equal to 50. All points are distinct. Okay, so we might have lots of points, right? So for each one, we basically want to find the smallest thing. So like we go looking up, right? So anything that's bigger than it we don't count. So basically we have 3 points. Right, we have 3 points, and then we're looking this way, and we have this is the smallest, and this is, so in this case actually we have 2, right? This one counts, and this one also counts. So if I have a smallest, right, vertical wise, that means nobody is in the vertical, and that one will count, because even if I have something that's bigger on horizontal wise, it will not interfere. So essentially, given something, we want to find vertical wise the smallest point with a y that's bigger than it, and the smallest point with x that's smaller than it, and we try to find that. Technically, I think at most you can have 2. At most you can have 2. You cannot have another one. So if we sort everything by their coordinates, so we'll sort first by their x coordinate, right? So like in this case, we'll sort by x coordinate, which will get 2, 6, 4, 4, and 6, 2. Okay, and then we sort by y coordinate, which is 6, 2, 4, 4, and 2, 6. So for each one, right, for 2, 6, I need to know, because this is sorted by x, we want to know the number that's smaller than 2, 6. There's nothing. Nobody is smaller than it, right? So on x, that would be 0. So for 4, 4, it's here, so we have 1. For 6, 2, we have 1, so that's 2. So now we're gonna go for vertical, right? Vertical. So 6, 2, no, vertical has to be bigger. So for 6, 2, vertical, the bigger one's 4, 4, but this one's already paired with 4, 4. So I need to have a pairing, right? We have to have a pairing. So this was already paired, so we don't count this anymore. Now for 4, 4, I have 2, 6, which is also paired, right? They're also paired. So that's also not going to count. It's paired. I think what we need to do, it's like a it's like a graph, right? This link to this link to this. So when I see, actually it's not the case. In this one, this link to this. In this case, this link to this. But essentially what we're saying is, start from 4, 4, we can find 6, 2, right? So this is also starting from 4, 4, we'll find a 6, 2. Yeah. Starting from this, we'll find, well, hold on. Starting from 4, 4, we find 2, 6. Starting from 4, 4, we find 2, 6. Yes, starting 4, 4, we find 2, 6. Maybe that's sufficient. Okay, let's try this. Let's try another example. So we sort on x. So on x is be 1, 3. Actually, it doesn't matter. 1, 1, 1, 3, 3, 1. Okay, and then sort on y. Ooh. Okay, I see. Yeah, it's a little bit tough to deal. All right, so for x, we need to look for smaller. So this one doesn't have. This one has 1, so we can say 1, 1 can go for 1, 3, and 3, 1 can go for 1, 1. Right? Now, so on y is gonna be looking to the right, right? Looking to the right. So 3, 1 go to 1, 1 I already have. 1, 1 go to 1, 3 I have, and that's it. I have 2. Maybe that's sufficient. Maybe that's sufficient. But I just realized that if we want to create this mapping, we need to have their index, right? We need to have the index to know. And each one can only have 1. You cannot have 2. That's false. It can have 2, right? It can have 2. So it shall be a list of sets. Yeah, what is a list of sets? And then we'll give this a try. Maybe this idea works. Each point has at most, so from a point, for each point, we can treat it as the bottom right and find what other points can serve as its top left. The candidate must have the smallest y than the points y, or the largest x that is bigger than, or the larger that is smaller than the points x. So thus we can sort points in 2 ways. right? I can sort the points in two ways. One based on x and the other based on y. Okay, one based on x, the other based on y. Yeah, the other based on y. We count, we record the mapping for one, and then do the same for the other while skipping any of the mapping already there. So we'll have open login. That's how I think this one will go, but we'll see. Okay, so we need to sort. We need to have a vector of a vector. Okay, I'm gonna change the point itself. It's not recommended, but I don't care. So points I dot pushback I. Okay, and then we're gonna have a vector of unordered set mapping of size. I probably need to say points dot size. All right, and then what we're gonna do is we'll sort by x and then y. Okay, so std sort points dot begin points dot end. That's it, because this is the regular sorting. We sort by x first, right, and then we sort by y. And then every time we just look to the left. The first one on the left is the one that we'll take. And then we say for int I equal to 1, I smaller than n, I plus plus. Okay? So we just take the one on the left, but we need to record its mapping. Right, we need to record its mapping. So we'll say mapping. Points I 0, 1, 2, right? This will map to. Ooh, that's actually not right, because if I look to the left, right? Because I sort by this, I look to the left. What I need. Hold a second. So. If my point is here, and I'm on the left, I have all these points, right? So what I need is a point that's, like, it has to be bigger than me, right? It has to be bigger than me with a y, and then the first one, which means if I sort based on y, based on x, so these, and then we'll sort based on y. Then we'll go like this, which is not ideal, because what I want is I'm going, so I'll go this, that's fine. I'll go left, I go this, I check, it's bigger than me, this, and then, okay, yeah, we have to go, then this is not, this is O(n) squared, right, plus n squared. All right, so now we're gonna go to the left, right? So for int j shall equal to I minus 1, j large equal to 0, j minus minus. So for each one, just say if points j 2, right, is larger or equal to if it's a larger or equal to actually, yeah, if it's a larger or equal to points I2, so this y is bigger than that, then we'll continue. Okay, but the first time that it's smaller, first time that is smaller, first time that it's smaller, then we'll do j plus 1. Right, first time it's smaller, we'll do j plus 1. So we say mapping points I 2 0 1. Oh shit, this is a 1. So that dot push insert points j plus 1 2, and now break. Actually, I think the easier one will be we just keep recording. Yeah, so okay, upper left, points j 2, okay, and then else will break. Yeah, we just every time we hit it, we just update, and when it's smaller, we just get out. So once we are done, let me say if upper this logic equal to 0. Well, we also can have int res as well, right? If it's larger equal to 0, then mapping points I2 dot insert upper left index, and then pair plus plus. Okay, now we go for the next one. Go on the next one. Once we're done, we're done. All right, so this is that. And then we're gonna say sort by y and then x. I don't remember how to do sort. Sort custom comparator. Okay, so it's going to be this. Maybe I just do this. Vector. If A1 is equal to a B1. So for this, I am going to look for the one bigger than me, right? Look bigger than me. And if I have a bunch of bigger than me, I will go looking for this. And it's the first one, right? So maybe at this one I don't really need to, because I'm here and I have all these, they're all bigger than me, right? So all I need to see is this is the one, which means if I sort by this, and then when this is the same, I sort by this. So I actually need to sort in reverse. Oh, but I also have this, right? I have a bunch of this, then yeah, I sort this first and then just go blah 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 blah, and then this is larger than me, then that's when we stop. Okay, so it's the same. If it's this, then I say return A0 smaller than B0, otherwise return A1 smaller than B1. Okay, so now we sort. Again, after we sort, we say I equal to 0, I smaller than n, I plus plus. This is for int upper left index -1, for int j equal to I plus 1, j smaller than n, j plus plus. Okay, so I go look for the one that has I, it's bigger than me, a y that's bigger than me, right? And then I will go through all of them, right, to find the first one, because they're all bigger than me, right? Because they are all bigger than me, but their x is not small. So I found the first one that it's y is bigger than me, and then its x is smaller than me, right? The first one, y is bigger than me, and then the x is smaller than me. So these are y is bigger than me. We want to find x is smaller than me. So we say if points j 0 is smaller or equal to points I 0, right? So if, because I sorted in increasing order, so I find it smaller, then we have to keep going because I'll find the largest. So I say, yeah, actually we can do that. So we can save, you know, like, say one line. Not bad. So here we will say upper that should equal to points j2, else break, which means the first time that I find a point whose it's bigger than me. Actually, hold a second. I don't really think you should break, because it's just something that's upper, right? And then it's on this side. Why do you break? You have to keep searching, and then you have this. It's just once it. Yeah, I don't really think you should break though. I think you should go through the whole thing. You should go through the whole thing, because as you're going, right? As you're going, they're all smaller than you, right? And then what you want is to find the one with the largest, find the one with the largest x that's smaller than you, okay? So we shall say upper left x is -1, okay? So here's the deal. If this, which means the x is smaller or equal to mine, and points j 0, because I need to find the largest. It's larger than upper left x. Then we do this, and upper left x is equal to points j 0. So same should be here as well. Should be upper left y. Right, upper left y. We want the smallest y that's bigger than u. Right, so we say if current is larger than this and points j1 is smaller than upper left y. Okay, if that's the case, then we shall update an upper left y shall equal to points j1. And then if we have this, we'll add it. It's the same thing. Once we have it, say if upper left index is larger or equal to 0, okay, and mapping points I2 dot contains upper left, and it's not containing, right? And it's not contain. Then we say mapping points I2. Well, actually, I don't even need to do this, but that's just for the sake of completeness. And then rest plus plus. And by the time we handle this, we can return rest. All right, so this is my solution. I'd say it's pretty straightforward, but we got it wrong, which is interesting. I got 3. How? I look to the left. Which is smaller, right? And compared to y, so that can only give me 1. And then I sort based on y. And then we go here. Listen to your heart. And I have 1. And I go here. All right, so I'm here if I go y. This is bigger than me. I think it's sorting has the issue. I think sort, because this sort by y. So it'd be this, this, and this. This, and this. So I look to the right. Right, I look to the right. And I need its x need to be larger. Now x needs to be smaller than me, so this is not. So yeah, now we got this one, and now we have here this one, and this I captured this because the way we sort. So the way I want it to be sorted. So everybody's on the left. And we go one by one. We hit, because in here they could be low. Right, so we try everything. How do we sort on Y? So we have the same Y. When you have the same Y, the biggest Y, the biggest X should go first. Right, so basically we have this, and the biggest X should go first. I use this, right? The biggest, so basically X sort in reverse, and then I go for every one of them to find the smallest Y. So I think then X in reverse. But for this, I think it's fine. Right, so we sort X and Y. So basically it will be the same X, so I have a bunch of Y's, right? And what we do now is we sort increasing, so we start from here, then we go, and then we need to find so their X is the same, right? Their X is the same. So their X is the same. Yeah, I think this doesn't really matter. So I check this one first. And then I check this. Maybe we should give it a little bit trial. So instead of 3, 1, I can have another, let's say 1, 4. We add another one here. Let's give it a shot. If it's not right, we'll debug it. It's not right. We'll debug it. So 1, 2, 3, 4, 5. So we have this 0, 5. 1, 2, 3, 4. We have here, which is 4, 4. I have 1, 1, 2, 3, 4, 5, 6. Here's 1, 6. Expected 2, but I only get 1. Ah! How does that happen? Right? How does that happen? Seriously, how does that happen? Sort by X. No, my bad. That's 5, 0. That's not 0, 5. 0, 5, 0, 1, 2, 3. No, 1, 2, 3, 4, 5 is here. 0, 5. Okay. I got 1 and I got 2. Yeah, there should be 2. So if I go sort by X, it's going to be 0, 5, 1, 6, and 4, 4. So 1, 6 try to go 0, 5. That's a no-go. 4, 4 go to 1, 6. That is a go. Oh, I see the problem. Huh. So if it's y is larger than it, and then as long as it's like it should be under the same x, we need to find the smallest. Maybe I need to change the algorithm a little bit. Yeah, I think I need to change the algorithm a little bit. Yeah, I need to change the algorithm a little bit. Now, this is not gonna make it simple. So basically, I need to go this. Maybe I should use a mapping, right? So basically, you can say, okay, when x is 1, not really. Not really, I think it's still here. We need to change. Hold on, that's the wrong answer. I need to put use case. So essentially, we're here and we put it in, right? We put it in. And then the next one, if it has the same as the previous, and if it's a new one, then yeah, so I'm looking at this. Okay, we get our upper index. Yeah, it has to be a bunch of them. Yeah, once the x changes, right? Once the x changes, so I need to reset. Need to reset the upper index. Okay. First of all, this I need to change x in reverse. Okay. So I have this. That's not right. Yeah, I do this, okay. So if this is larger or equal to this, and we say if j is equal to I minus 1, it's the first time that we change. The first time that we change. Okay, if j is smaller than I minus 1, okay, so j is smaller than I minus 1, and points j 0 is smaller than points j plus 1 0, right? So basically we say there's a change in x that we know mapping points I to the insert points j plus 1 to res plus plus. That is not true. That is not true. Because what we want is the smallest that's bigger than. Okay, so we still need, so this has to be this, and oh yeah, I have this. This is a y. Y is larger than the current y. Okay, y is larger than the current y, and then I say okay, what was the previous? I think I'll return to the previous, honestly. So instead of doing this, I do want to say the upper left x, okay, upper left y. Upper left y upper left y and upper left x. Yeah, let's redo the whole thing. Okay, let's redo the whole thing. So now we say point J1 is larger than, okay, so we have something that's larger than. Then what we need to do is set if upper left x is not equal to point J0, upper left x equal to point J0 and so whenever there is a change, and upper left x not equal to, I'll record it's this and then it's y. And x if it's the same, now I just update. Same as update, same as update. And then it becomes different again. Right, then it becomes different again. So when it's different again, then I need to record. But how do you handle the initial? Right, how do you handle the initial? Yeah, so when it's changed, we'll record the previous one. I say if upper left index is larger equal to 0, we do this. Otherwise, we'll update upper left and then upper left index will equal to points J2. Alright, this is if it's not the same, which means we have an update. If we have an update, then we'll record the previous upper left index, we'll insert it, do this, update upper left x, and we need to update upper left to right as well. So upper left y is going to be points J1, right? Okay, now we have if else, then upper left y shall equal to it's sort on y, so you can just always update y, which means you don't really need y, right? You don't need y. All you need to do is just update index. Then you don't really need index because you will be updating index here as well. So why do you need index? You don't need it. You just need to keep track of x. Interesting. I do need to keep track of x index, right? I do need to keep track of this, because this tells me if there's any change. Because I could go through a bunch and then we go to the new one, right? Then it's not the same, and then previous I set it, then I'll get the new one set. Okay, yeah, I don't think I need this, but I don't think I need these two. Upper left x, right? If it's not equal, then we do this, and we'll, oh, hold on, I do need this. Upper left index, I do need this. And if it's not equal, I update this. And then upper this shall always equal to points j. This one always gets updated. This one always gets updated. Because it's larger than, so I always update. Right, and we are going in the direction of the y becomes smaller, right? Y becomes smaller. So yeah, every time we'll update, once it's not equal to the current, right, which means we have a change, then the previous one need to get updated, right? Previous one gets updated, but it doesn't matter. And if it's the same, which means this one doesn't even have to be in here either. I can just put it on the outside. That's right. I can just put it on the outside, and then we have a bunch that's like that. We skip, and do it again, and then we have the previous update left, which we don't really need to keep track of the update left, right? Why do we need to keep track of update upper left x? All we need to do is to check, right? Because if like this, and your current point is good, and I want to know if the current and the previous, if their x is the same, right? If their x is the same. If their x is not the same, which means I don't think I even need to do this. Here I can simply say, no, j plus 1, right? Yeah, if j plus 1, the x is not the same. So if the x is the same, what if the x is the same? Now, if the x is the same, and I am going from here coming down, so I'm at here. Huh? It will never get caught here. I think it will get caught sort by y, the x in reverse. Yeah, I sort by X. So everything I see. And then what if I sort Y in reverse? Then we go this one first. Nah, I feel this is just making things a lot more complicated than it needs to be. I think I need to rework the original, which means if you have the same X, you count how many they are, and it's deterministic how many you can make. If I have like 3, you can make 2, right? Okay, they're in one line. They're in one line, so this is just deterministic. You can make, and then but every one of them can still make they cannot make. So like if I am a bunch of this like here, and I have something, let's say here. Okay, so this I can make with here, this can make here, this can make here, right? But this cannot make any, like they just done. You can't make with any of the things on here, because if this want to make with this, it will overlap with this. That's not true. Like this can still make. What the hell? Let me think again. Do you feel you're overcomplicating this thing? I do. How about this? Screw all of this. We just do pairs. O(n) squared, we get all the pairs. And once we get the pair, we just find if there's another point in between. How do we do that? How do we make sure there's no other point in between? So when we get a pair, I have a range, right? On the X, I have a range. On the Y, I have a range. All we need to know is, does another point exist within this range? So I say X, I have a range. I need to go through that to see if there's any point that's within. There can be multiple, right? And then we do Y, and we find multiple, and then you just need to make sure that they do not overlap. There's not a one that's kind of in all of them. I mean, you can just, it's 50. So you can do O(n) tripled. You just run another one. Right? And maybe there's a more difficult version of this. We'll just deal with it when it is time to deal with it. I kind of, because it's late, I don't want to, I think I'm just going to brute force it. For each one, we're going to go through this whole thing again and then try to see if it's inside. if it's nothing inside, that's a pair. All right, screw this. We're gonna brute force this. I think brute force can work because it's just 50-50-50, right? I think brute force will work. The sorting idea will work, but I feel there's a lot to think. There's a lot of logic, right, to deal with. Given that n is smaller or equal to 50, let's just brute force this with O(n) tripled. All we need is a auto function, right? Is in. So is this I, J, K? Is point K in the rectangle bounded by points I on the top left and points J on the bottom right? So return points J. If it's in, then points J is 0. It's X. It can be larger or equal to points I 0 and points J 0 need to be smaller or equal to points J 0. Okay, all those, this is actually K. This is also K. And points K1 is smaller or equal to points I1 and points K1 need to be larger or equal to points J1. Right. So that is in. Also, auto is top left, bottom right. Yeah. Is points I top left and points J bottom right, or points I we can sort. I think we should still sort. Once we sort based on X, so at least we know as we go, right? I, and then j will be this, so at least I know it's going to be on the left hand side, right? Everything's going to be on the left hand side. Yeah, so at least this one's good. And then I just need to do this, then I know which one is I, which one is j. And all I need to do is I have these two, and then we just need to go through everybody else and let's make sure that yeah, I'm here and I'm here. Because it has to be on the left hand side, right? So I say this is the bottom right. Okay, if this is the bottom right, I have all of us on this side. Who can be my top left? Right, who can be my top left? So the top left will be, just go through everybody in here. So we get one, right? We get this, it's like closest to it. And then what we do is we go through everybody else. Okay, so we still sort, and then we say this is the bottom right, and they might be the, so we go through every single one. So for each one, the y has to be bigger. Okay, so now we have a candidate. So after we have a candidate, what I need to know is for everybody in between, right? Because it cannot be towards the left. Actually, it can be towards the left, right? It can be towards the left. So I just like for one, we just search for anybody in between, and if anybody in between, then it's going to be so we need to sort it increasing then, right? We need to sort it increasing because we need to sort it decreasing. So we get this is going to be the smallest, right? So that's going to be the smallest, and that's not true. That's not true. Okay. So we get something smaller, and then what we need to know is everybody. Once it's become smaller than that, then we just stop. So it will be like this. We'll sort. Okay. We'll have res. Right. Right. So now I have I and j. So what we're gonna do, okay, I have I and j. What we're gonna do is go through every one that so now I have I and j. Then we go through every one what is smaller than I. See, if nobody's in it, that's a match. And we'll try another one. We'll try another one. We'll try another one. We'll try another one. So if points I 0, no, 1. So you have to be larger, so smaller you go to points j 1. Okay. Now points I is a candidate. Oh, this has to be the bottom right. This is on the top left. Let points I be the bottom right. Points j is a candidate for top left. Okay, we want to find if there are any other points to the left of points I that are within the rectangle bounded by points I and points j. So we say for int k. So it won't be bigger than j, right? Because it's sorted. So those will be bigger. So it's going to be just smaller than j. So j minus 1. K larger equal to 0. K minus minus. K larger equals 0 and points k, its x has to be larger or equal to points doesn't make no sense, man. Because I can do something here, okay? Then I cannot keep looking to the left, right? Points. It doesn't make any sense. So this has to be I minus 1. Right, I minus 1. Right, and then this point is the same. It has to be this, has to be above, that's below, it just don't count, but once you cross it, then that's the end. Because once I cross it, this is no point, right? Points j 0. Okay, k minus. If points k 1 is, I say I1 is smaller or equal to points k1 and oh, that's just we are reinventing the wheel, is in ijk. Okay, so here we need to say boolean is good. Okay, so it's good is true, but once one of them is in, that means is good is false, and then we shall break it. Right, so it's bad. So the goal is to go through every single one in between k, in between j and I, right? Because j is to the left, it's up, And then we just go from every single one. It's okay to go beyond as long as it's larger or equal to the x, right? Then we're good. And we just see if it's inside, right? If it's not inside, it's good. But if it's inside, then that's bad. So then we'll break it, and once we get out, we see if is good, then we say res plus plus, right? Or res plus plus is good. Oh, I think I can do res plus equal to is good, right? And then yeah, just like that, I'll go through all of them and then I will return result. Okay, that's the second solution. First one apparently didn't work very well. Let's try the second one. Hopefully this one will fare better. Oh my god, this one's even worse. What the hell? Oh, seriously, what the hell? Alright, I don't understand why. Alright, I don't understand. What the hell? I mean, even the second one was wrong. How? It will be in this order, right? So I'm here. J will be this. Right? And then if J is this is large, J1. I1 smaller equal to J1, yes. Is good should be true. Because K will be equal to this, right? K is equal to this. Oh, it cannot be equal to, okay, hold a second. All right, for one thing, okay, this is fine. And then if is in, so K is not equal to J. And the K equal to J, that's just doesn't work. Okay, we got a few, but now we got this one still wrong. Output is 1. It's supposed to be 2. Yeah, I still don't understand. Probably with the sorting again. With the sorting again. What if I just start from n minus 1? Just like screw it. I just go n minus 1. I say screw it, I'll go through every single one, and there's no n. Dear me. Hold on, I'll create an n. Okay, I created an n, so this is n. All right, let's try. So this basic, I just go through everybody. Now it is terrible. Wait, what? How? I'm going through every single one. How is this not working? I don't understand. Oh, I know. And k is not equal to I. Because I'm going through every single one, so I have to do both. Oops. What? All right, that's too much time. I'm gonna check the answer. I cannot believe it. This doesn't feel like that difficult if I just go with just brute force. I don't understand. Copy and paste. I have to deal with this tomorrow. Dear me. Something is not right. Okay? Something is not right. Let's get it passed first, and we'll go back. Let's go to the last submitted code. All right, so this is not right. Hold a second. What I want is this one. Oh shoot! I didn't even submit it. Jesus. That's right. We're gonna work on this one again. Okay. I feel like it's like what's the difficult about this? You pick two, you go through everything, and then voila. Right? I mean, how? I don't understand. I honestly don't understand. We sort the points, and then we go through every single one. I don't understand. Okay, how about this? Let me do this. Points.size, okay? And I say screw you. Okay, I say screw you, which is perfectly fine. I say k equals 0, k smaller than n, k plus plus, okay? If, k is not equal to I, and k is not equal to j, and this, then it's bad. How about this? This has to be right. I'm not even doing anything smart. I'm doing absolutely just brute force. I go through every single one. And how is this still bad? I don't understand. It might as well not sort it then. So if I don't sort, and then we'll go through everything. Jesus. Go through everything. You might double counting then. You might double count if you do this way. Yeah, we might double count. So let's do this to make sure we don't double count. So what we want is for J to be the, okay, so which means this and points I 0 had to be larger or equal to points J 0. I don't understand. Okay, at this point, I have no clue why. It seems like torture. Like how? I'm already doing... like what the hell? Okay, so we have to deal with this tomorrow. I don't understand. I don't understand at all.